been there and seen this, and it's a pretty incredible technology. Go ahead, Alexander. He doesn't need a microphone.
I'll try to yell. So I think
good.
the room is big enough so that I'm not going to need the mic. So I'll go straight to the problem that we're trying to solve, and that is scaling blockchains. And I hope I'm not going to have to spend a lot of time on this first slide to convince you that scalability is the biggest obstacle in the blockchain space. Currently, the throughput of a blockchain is measured in terms of the number of transactions per second. Okay, how many transactions can a blockchain serve per second? Bitcoin currently serves 3 transactions per second. That means 3 persons in the world in a single second can send their transactions to other people. If you're 4th in the line, you have to wait for another second. Okay? Ethereum is a bit better, they have 10 transactions per second. And if you look at the real-world applications out there, there is a huge gap. For example, credit cards, Visa alone has 5,000 transactions per second. If you just look at the number of cars in US, okay, and assume each one needs to fill their tank once a week, just for that you need 450 transactions per second. Okay? If you look at vending machines and assume each one is used only 4 times a day, you're going to need 1,000 transactions per second. Just for that, nothing else. Okay? And I'm not even going to talk about these machine-to-machine communications and global micropayments. It's embarrassing to talk about that when the current throughput is so low. Okay? Why is it so low? Let me try to explain it. It's not rocket science. It's actually fairly simple to understand. Okay? So, in Bitcoin, a transaction is, the size of transaction is 540 kilobytes. 540 bytes. I send 1 Bitcoin to somebody else, I sign it with my private key, I send this piece of data to somebody else. This is a Bitcoin transaction. Okay? Each miner in the system produces the lucky miner, whoever mines a block, sends 1 megabyte every 10 minutes on average. Okay? If you divide that 1 megabyte with those 540 bytes, you end up with about 1,900 transactions every 10 minutes. If you now turn these 10 minutes to seconds, this is 900 transactions divided by 600 seconds. This gives you around 3 transactions per second. Okay? And so, just looking at these numbers, few ideas come to mind. Like, it appears that this might be solvable. Maybe we solve this on slide number 2, and I don't have to talk anymore about this. Maybe. Look at this. It says 1 megabyte block every 10 minutes. Why not send 300 megabytes every 10 seconds? That's going to give you a huge throughput, right? So let's try to do. The question thus is, what is the problem? What's the problem here? Well, the network is the problem here. Look, that's a Bitcoin network having 10,000 nodes and plus 100, a large number of nodes. Okay. If there was no network, it's easy to send a large number of transactions from one machine to another. That's not a problem. Okay? So the network is the problem. And cryptocurrencies use this peer-to-peer network propagation, which is anything but optimal. Okay? It works, it's good, it gives you something, but it's not efficient. Okay? So the question is, well, listen, let's try with the previous example. Let's try to increase the block size. Let's try to change that trade-off that we get. 10 minutes, 1 megabyte block every 10 minutes. Okay? So if we increase the block size by 10 and have 10 megabytes blocks, that's going to work fine. The propagation is going to be a bit, it's going to take more time. Hence, there's going to be forks. Fork is a case where not all members in this network are on the same page. Some of them think one blockchain is the right one, another part thinks another one is right. So if we increase this by 10 times, it will still work. There's going to be some problems, but it can work. If we do this by 100 times, this goes to hell. It just doesn't work. Everybody's thinking, oh, I'm right, I'm doing something, and then some other piece of information is coming, and it just unravels. It just doesn't work. Okay? So at this point, I'd like us to stop for a second. And I just told you, 10 megabytes every 10 minutes, that's not going to fly. Now, let's think of another system. Let's think of YouTube. All of us should know what a YouTube is, okay? Or at least our kids use it, okay? YouTube sends terabytes of data every single second, and they have 1.3 billions of users in the world. So if you look at these two things, somebody here is mad or crazy. Something is wrong here. Because here I'm telling you 10,000 users, 1 megabyte every 10 minutes, and on the other hand you have billions of users, 1.3 billion users, sending terabytes of data every second. So the question is, why can't we use something advanced as that and put it in a blockchain to work? Okay. And this is precisely what we're doing. What we're doing is, you're building a thing called the blockchain distribution network. Okay? A blockchain is, you can think of it as YouTube of blockchains, or Akamai of blockchains. Okay? Something that helps blockchains resolve this information propagation problem. So we can do this much faster. It goes between 1,000 and 10,000 times we can increase the throughput of any blockchain, not just Bitcoin or Ethereum. Okay? We run under all cryptocurrencies, and hence our target customers are all possible cryptocurrencies and all possible blockchains. Okay. As it was said, we require no change from a blockchain. We don't require them to do anything, and our system can be gradually deployed. And now we have to stop again. Like, so this looks so far, it looks so easy. Like, how come? Like, what's the issue here? All right? I mean, how come nobody else came up with this? It's a simple thing. Just throw an advanced cloud network on this and it's going to fly. But the real problem, we solved the scalability problem. I mean, at least I hope I convinced you here. The performance is no longer a problem. But now we have a very powerful player, which is our network, thrown in the middle of this blockchain community. And the blockchain, the key idea behind blockchain, is that nobody owns the protocol. It's a completely distributed system, and there is nobody who has the power to stop or do anything with this network. So once we throw in this huge beast of ours in the middle of a blockchain, we have another problem. And that problem is, how can we prove to these nodes in a blockchain that we aren't doing anything fishy and that we are actually probably neutral? Okay? So the big problem that we are solving is the problem of probable neutrality. And I'll be very blunt with you what that means. That means if FBI or NSA or somebody comes knocking on a door and says, listen guys, we have this particular Bitcoin address, and we know that these are some very bad folks. They're doing some very bad things. Okay? So whenever you see such an address, please call us and don't let that transaction go through, because bad things are going to happen. Okay? Our answer to that problem is, dear FBI, NSA, whoever, we equally don't like any of these bad folks, but there's absolutely nothing we can do about this, because our protocol is designed such that we cannot interfere. Because all the traffic is encrypted, and all the entire system has been audited by these endpoints. Okay? Another example is, consider somebody comes to us and says, look, this country X, we don't like them for whatever reason, please stop serving traffic from that country. And we can say, listen, we can do that, but it doesn't help, because as long as there are nodes in other parts of the world, everything still works fine, and there is nothing we can do to prevent a particular geographic location or particular country to not be served by our network. Okay? And because not everybody here is techie, and I'm just really trying to send a message like, so what did we do here? If I would have to make an analogy of like, what is that we designed here? Think of a probably efficient, neutral, non-corrupt, low-taxing government, audited by the people. This is something that we, the humans, are trying for thousands of years, and it's unclear if we're there yet. I mean, here and there, there's there are hopes that we are getting there, but really think of such a system. We created that for the internet. Okay? this is all cool and nice, and I'm actually, net neutrality is something that I'm, like my career project was on net neutrality, so I'm very passionate about this stuff. This is all cool and nice, but the question is, how do we make money? Not because we want to be millionaires or billionaires, we do want to do that. However, the key question here is, how do we make this sustainable? Who's going to pay for this now? It's expensive operation, okay? So here is how it works. Currently, in Bitcoin, Alice buys an apple from Bob. This is just an example. And then what happens is that Alice creates a transaction. It looks like this. Bob gives 9 Bitcoins, or whatever currency puts on that transaction. It pays a fee of 1 to the miner, and has the total is 10. Okay. This is what it looks like today. This is a hypothetical example. Okay? Even though this fee today in Bitcoin can go as high as $10, which is completely against the whole idea of Bitcoin. It should be much lower. Okay? So what is our model? Our model is Bob still has to pay for the apple, 9 points. That's given. We can't help there. This is between Alice and Bob. The miner fee is 100 times smaller in our case. Hence, instead of 1, it's 0.01. Our fee is 10% of the miner fee, which is 0.001. And hence, at the end, you have 9.011. 9.011 versus 10, what looks better to you? Okay? So, how do we get there? Well, we get there by aligning incentives of all the possible players in this particular field. Okay? What does that mean? Well, the users get 100 times smaller fees. Because there's so many, much more transactions, we can actually achieve that. The miners are getting smaller fee per transaction, however, they are capable of serving a much larger number of transactions. And hence, in this case, because we assume 1,000 times increase in throughput, this means 10x more money for the miners. And we are getting 10% of the miners. Okay? So if you look at this from the big picture, the big picture is the value that we're creating, we leave 99.9% of that value, we leave it to the existing ecosystem. Okay? We give it to the users and we give it to the miners. We take 0.01%. And before you start feeling sorry for us, like, hey, you guys are crazy, I understand that the idea here is to provide, to give some understanding of where we're going with this. Okay? So, well, the question is, so what if we have large scalability? Well, we can do things such as micropayments. What does that mean, micropayments? Does it mean somebody's going to get rich? What kind of applications are we doing? Well, if you have micropayments, for example, you have these things called like, oh, that video went viral. And it got like $1 million. So what do you get from that? Nothing. Like you go tell to your friend, like, hey, somebody downloaded my video 1 million times, isn't that fantastic? It is fantastic, but assume a scenario in which everyone who downloaded that video puts 1 cent to whoever created that video. And hence you wake up with $10,000 in your pocket instead of just having $1 million. Okay? There are numerous other applications where micropayments, and not just micropayments, but many distributed applications where this is. I am a guy who works in the internet. Imagine the world in which each and every router on the internet or middle box or switch becomes an independent economic entity that is betting and that is providing its services, that is earning money. That becomes a completely different world. Okay? And there are many other applications. I'm not going to dive into that because I'm running out of time. But I mean, our mission is to be at the the leader of this revolution, and we really want to make all these things possible. This is what keeps me up at night, right? Because I see a lot of, and this is how we do it. 50% of the revenues created by bloXroute goes to the company, and the other 50% goes on a pile called BLXR reserve. Okay? And this reserve is directly connected to our token. If you have 1% of BLXRs, you can go to that pile and get 1% of these tokens at any point in time. Okay? The pile can never go down, it can only go up. Even if somebody cashes out, the remaining coins stay there. Okay? And what we believe, and where we're going with this, we are creating something that we believe is a future crypto index. What does that mean? That means there are a bunch of coins out there. Which one of them is going to be worth tomorrow? I have no idea. Seriously. I mean, I have my thoughts, I have my intuition, but how do I know? But the point is, whichever becomes big in future, we should be serving that coin, and our BLXR is going to be heavy with that particular coin, and this is the context in which I'm looking at this. I will quickly go through the team and so on. So this is a collaboration between Northwestern and Cornell. My colleague from Cornell, Professor Musir, who's one of the most important academics working in this domain. We and two of our students are co-founders of this company. But we're not just academics. We academics are sometimes good at coming up with ideas, sometimes good with writing papers, but when it comes to actually executing an idea, that's a whole different ballgame. Okay? So we have that guy in the middle, Dale Matkovic, he's our COO, he's an industry guy, he's a former VP of engineering of Caminario, and he's really making a huge difference and